Today we are going to see the trigonometry. Before that trigonometry, we have to discuss about the angle. What is the definition of angle? Previously in 10th standard, you know that the angle is a union of two non-collinear rays. It is not sufficient. It is not sufficient. Now we are going to see that is the order pair. This is the order pair. It is important to order pair of ray OA and ray OB. Okay. Together with the amount of rotation, ray OA, ray OB, order pair of rays, together with the amount of rotation of ray OA so as to occupy the position of ray OB, that is amount of rotation of ray OA so as to occupy the position of ray OB. That amount of rotation is called an angle. No degree, nothing else. Angle is the amount of rotation. Angle is the amount of rotation. So again, I define that ray OA, ray OB. This is the order pair. Ray OA, ray OB. Together with them, the amount of rotation of ray OA so as to occupy the position of ray OB. OA rotates and occupy the position of OB. That amount of rotation is called directed angle. That is denoted as directed angle AOB. Again I repeat, in short, that is order pair of ray OA, ray OB, together with them, the amount of rotation of ray OA so as to occupy the position of ray OB is called a directed angle, denoted as directed angle. Read it, directed angle AOB. Direction is very important. Listen here. Who rotates OA? So ray OA is called initial ray and ray OB is called terminal or final ray. Terminal ray, initial ray, and point O is called vertex of the angle. Yes? Do you follow that? Yes. What is angle? Only, just remember, amount of rotation. What is angle? Amount of rotation. Whose amount of rotation? Ray OA is rotated so as to occupy the position of ray OB. That amount of rotation, that is called an angle, right? Who rotates OA? It is called initial ray. What is the final position? OB. It is called terminal position. What is the point O? Is called vertex of the angle, amount of rotation. Okay. Now here, if the rotation of OA is in anti-clockwise direction, then angle is considered to be positive angle. If the rotation of initial arm is in anti-clockwise direction, the angle is to be considered as a positive angle. And if it is in clockwise direction, then angle is to be considered as a negative angle. I have not told you that is a degree, 30 degree or 40 degree. I don't know what is the degree. I only know that angle is nothing but the amount of rotation of any ray. Right? So this is a basic part of that. Now we turn to, types of the angle. Yes. First is that zero angle. Zero angle. Listen. Here is ray OA, ray OB determine directed angle AOB such that initial arm, that is ray, and terminal arm ray lie along the same line and in the same direction without any rotation of initial arm. What is that? Ray OA, ray OB determine this is the directed angle AOB such that initial arm ray OA, terminal arm ray OB, that is terminal arm ray OB, they lie along the same line and in the same direction without any rotation of initial arm. Without any rotation of initial arm. Such an angle is called a zero angle. It's called a zero angle. A straight angle. Straight angle. This is again same language. Listen. Ray OA, ray OB, same language. Ray OA, ray OB determine directed angle AOB as I have shown here such that initial arm ray OA and terminal arm ray OB lie along the same line. Yes, it is, but in the opposite direction. That means OA and OB are opposite rays. So the angle determined angle AOB, that is directed angle AOB, is equal to straight angle. Right? Straight angle. In a straight angle, same definition, no change. Ray OA, ray OB determine directed angle AOB such that only change initial arm and terminal arm lie along the same line but in the opposite direction. They are opposite ray of each other. The angle determined is directed angle AOB is a straight angle. It's a basic definition. Third one is that here. Complete or whole angle. It's a basic definition. Remember that. O, A, B. Ray OA, ray OB. See that? Language is same. Only positions of initial arm and terminal arm to be noted. Ray OA, ray OB determine directed angle AOB, same, such that initial arm ray OA, terminal arm ray OB lie along the same line and in the same direction after completing a one rotation of ray OA about O. See that? Initial arm OA, terminal arm OB lie along the same line. Position is same line of the zero position. But after completing a one rotation of ray OA about a point O. So this is a complete angle or the whole angle. The basic definition, that is zero angle, straight angle, a complete or whole angle. Follow there? Yes. Shall we start there? The next minute. That is angle in standard position. Angle in standard position. Right. Here a frame of reference. Now ray OA, ray OB determine directed angle AOB. No BOA. BOA means in which OB is rotated. AOB means OA is rotated. Now here, the initial arm ray OA lies along positive direction of x-axis. Remember that. Initial arm ray OA must lie along the positive direction of x-axis, and the terminal arm may be anywhere, right? So this is, and whose vertex of the angle is origin. Vertex must be origin. Initial arm lies along positive direction of x-axis. The angle is called angle in standard position. Angle in standard position. If terminal arm lies any quadrant, say that is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4, for any quadrant, right? Then we say that angle is in quadrant. Angle is in quadrant. See, first of all, angle is in standard position, right? And then its initial arm OA lies along positive direction of x-axis, and the terminal arm lies in any quadrant. It is said to be angle in quadrant. And but if OB lies along any axis, say OA, see OB, or maybe here OB, or here maybe OB. So this is angle, or this is angle, or this is angle, like this. If the terminal arm of angle in a standard position, terminal arm of angle in standard position lie along any axis, like this, any axis, the angle is called quadrantal angle. Is called quadrantal angle. And here angle in quadrant. Angle in quadrant. Now listen here, revise. First of all, ray OA, ray OB determine directed angle AOB, right? AOB, no BOA. BOA is OBOA. AOB, OAOB, such that initial arm ray OA, terminal arm ray OB lie along the same line and in the same direction without any rotation, no rotation, zero angle. And after completing one rotation, same position, a complete or whole angle, right? Third, straight angle, ray OA, ray OB, determine directed angle AOB, initial arm ray OA, terminal arm ray OB lie along the same line, but in the opposite direction, correct? So this is called a straight angle. Followed? Third one, angle in standard position. Very important. The angle in standard position, that means initial arm must be along positive direction of x-axis. Vertex of the angle is origin, right? So this is angle in standard position. If terminal arm lies in any quadrant, the angle in quadrant. For example, terminal arm lies in first quadrant, angle is in first quadrant. Terminal arm lies in second quadrant, angle is second quadrant, etc., etc. But if the terminal arm lies along any axis, then it is called quadrantal angle. It completes of one quadrant, that's quadrantal angle. Yes, now we know that is an angle in standard position, straight angle, zero angle, etc. We know that. But how to measure them? How to measure? What is to measure? Measure of angle means what? A measure of angle is nothing but the measure of amount of rotation. What is that? Amount of rotation. How to measure it? You'll come to know that how to measure it. Yes, there are actually 3 systems, but we are discussing 2 systems because third system is not there. So first system is called a sexagesimal system, in which, that is sexagesimal system. In the sexagesimal system, that complete angle is divided into 360 equal parts. How many parts? 360 equal parts. Equal parts. And each part, that amount of rotation, each part, that amount of rotation is called 1 degree. This is a degree, 1 degree, denoted as 1 and degree. Each part. So total round, a complete angle is divided into 360 equal parts, right? 360 equal parts. Equal parts. Each part is called 1 degree, denoted as 1 degree, like this. So in that case, what happens? Straight angle is equal to 180 degree, and a complete angle is equal to 360 degree. Apart. Further, if the rotation is less than the 1 degree, so consider here 1 degree. This is 1 degree, say 1 degree. 1 degree is further divided into 60 equal parts. 60 equal parts. 60 equal parts. Right. Each part is called 1 minute. 1 minute, denoted as 1, like this, minute. Read it, 1 minute. Further, 1 minute is taken here, and 1 minute is divided further into 60 equal parts. This is 1 minute is divided into 60 equal parts, and each part is called 1 second. That is 1 second, like this. So I have the relation in the sexagesimal system that 60 seconds is equal to 1 minute. 60 minutes is equal to 1 degree, and 360 degree is equal to a complete or whole angle. It's the first part. Or in sine, 60 seconds is equal to 1 minute, 60 minute is equal to 1 degree, and 360 degree is equal to a complete or whole angle. Whole angle. So this is a sexagesimal system. See, first figure here it will give you that a 1 complete rotation is a whole angle. Then a whole angle is divided into 360 equal parts. Each part is called 1 degree. Further, 1 degree is taken here. It is divided into 60 equal parts. This is 1 degree, right? 1 degree is divided into 60 equal parts. Each part is called 1 minute. Further, 1 minute is divided into 60 equal parts. Each part is called second. We have now the complete system. That is a sexagesimal system. We don't know in 8th standard, 9th standard what we have done that 30 degree, 40 degree. What is the meaning of that? That means only on this picture there is a 30 degree, you are drawn the 30 degree. And that is not the way. 30 degree, 60 degree, 30 degree means what? I'm going to explain now, just now. See that. So this 1 minute is divided into 60 equal parts. So each part is called 1 second. And therefore, we have a complete relation in the sexagesimal system that 60 seconds gives you 1 minute. 60 minutes provide you 1 degree. And 360 degree provides you a complete, a whole angle. Right? So this is a method. This is the first method. Now, for example, what is the meaning of that? 24 degree, 32 minute and 41 seconds. What is the exact meaning of that rotation? See that. The sign is a positive here. So I say that. So listen it carefully. Huh? Yes. Now, the initial arm start to rotate. Initial arm start to rotate. In which direction? Positive. Anti-clockwise direction. Anti-clockwise direction. Right? Now, how many parts are there in full complete angle? 360 parts are there. So, first it completes the 24 part. It comes here. 1, 2, like this. Up to 24 parts it will come here. Now, that means he will not reach to 25. So in between 24 and 25, there are 60 equal parts. So out of that, it completes a 32 parts. Then from 32 to 33, because there are 60 parts, 32 to 33, there are again 60 equal parts. Out of that, it completes a 41 rotations. So this is a rotation and this is angle 24 degree, 32 minute and 41 second. One more example. Minus 40 degree, 20 minute and 10 seconds. That is initial arm. Start to rotate in clockwise direction. Clockwise. How many parts are there? 360. How much part it will complete? 40. In between 40 and 41, there are 60 equal parts. Now it completes a 20 only, not 20 to 21. There are again 60 equal parts, right? In that it will complete a 10 parts. So this is amount of rotation. Follow there? So this is the meaning of the exact angle. Now second system is called a circular system. It is observed that circle is drawn here. So many circles are drawn. Listen here, it's a center. That is, this is an arc of the circle. This is an arc of the circle. This is an arc of the circle. This is an angle subtended at the center. See that. If the radius of this circle is 2 centimeter, if the radius of second circle, this is this one, is say 5 centimeter, and this is a radius 8 centimeter. That is arc length. This arc length is equal to a radius. Arc length is equal to radius. It doesn't mean that that is a radius. If radius is equal to 8 centimeter, so arc length is equal to 8 centimeter. Radius is equal to 5 centimeter for the second, the arc length also equal to 5 centimeter. The radius is equal to 2 centimeter, then arc length is equal to 2 centimeter. Then the angle is same, no? Angle is same. So what is said that angle subtended by the arc, angle subtended by the arc of the circle whose length is equal to radius of circle at the center is always a constant, and that is taken as a 1 radian. This is called 1 radian. Correct? So, this is a unit for measuring the directed angle in a circular system known as 1 radian. What is a 1 radian? See that. 1 radian, like this, see. That is a notation, 1 radian. Read it, 1 radian. 1 radian is the angle subtended by the arc of the circle, whose length is equal to radius of circle. It doesn't mean that that's a radius, remember that, whose length is equal to radius of circle. It is always constant for all the circles. I'm going to prove that for this. Listen here now. That is observe here carefully. Ray OA, observe carefully, yeah? Ray OA, ray OB determine directed angle AOB such that angle AOB is equal to theta. Let us assume that. Correct? Okay. AB is an arc of a circle whose measure angle AOB is equal to theta and arc length is equal to length of arc AB is equal to R. Say I'm taking the length of an arc. For example, radius of this circle is equal to 5 centimeter. I have taken the AB as a 5. So length of an arc is equal to R. Yes. Take a construction here. See. Diameter AC is drawn through A. Therefore, arc ABC is semi-circle arc. See, its measure is equal to directed AOC is equal to, I can understand that is straight angle. It's a constant angle, straight angle measure, and length of arc ABC is equal to ABCR is equal to semi circumference is equal to half into 2 pi r is equal to pi r, length of arc, and its measure is equal to straight angle. Now, as you know that if arc length increases, the angle also increases. So therefore, can I say like this? That is, length of an arc is directly proportional to its measure. Am I right? Length of an arc, as length of an arc increases, measure also increases. Right? Now therefore, I can say that length of an arc is equal to K times its measure. K is equal to constant. Yes. Now here, when length of an arc AB is equal to R, then its measure is equal to theta, Therefore, can I say that length R is equal to K theta? That is my equation number 1. R is equal to K theta, right? When length of an arc is equal to AB is equal to R, then its measure is equal to theta. So therefore, R is equal to K theta. Now, when length of arc ABC is equal to pi R, that is here taken pi R, its measure is equal to straight angle, because here we have taken the circumference, length of an arc, pi R, its measure, straight angle. Therefore, can I say like this, length of an arc ABC, pi R is equal to K into straight angle. K into straight angle, that is number 2 from. Now taking the ratio of from 1 and 2, what we have? R upon pi R is equal to K theta upon K into straight angle. K cancel, R cancel. Therefore, that is straight angle upon pi is equal to theta. As straight angle is constant, pi is constant, therefore straight angle upon pi is also constant, and therefore theta is constant. But theta is what angle? Theta is the angle subtended by the arc AB with the center. And who is the arc AB? That is equal to radius. But it is not a radius, length equal to radius. Therefore, I come to that statement that angle subtended by the arc, whose length is equal to radius of circle. It is not radius, length equal to radius, always a constant, and that constant is treated as a 1 radian. If draw the circle of 5 centimeter and take a radius equal to 5, that is arc length is equal to 5 centimeter. That student, he draw the circle of radius 10 centimeter and arc length is equal to 10 centimeter. Whatever the angle at the center is the same as to angle made by that thing. And therefore, since this is a constant, if I draw the circle of 100 centimeter and I have taken the arc length 100 centimeter, so my angle is same as to that student, and since it is a constant, theta is constant, it is taken as a unit for measuring the angle in circular system, and that is known as a 1 radian. And that's why we have defined that 1 radian angle is the angle made. 1 radian angle is the angle made by the arc of the circle, whose length is equal to radius of the circle at the center is always a constant. And this is taken as a 1 radian.